Imagine looking up and seeing a drone not just filming, but actively building a skyscraper or repairing a wind turbine blade mid-air. This isn't science fiction. We're on the cusp of an era where the buzz of a drone will signify more than just an aerial camera. It will herald the arrival of a new kind of worker, an autonomous flying robot capable of performing complex tasks in places no human can easily or safely reach. This is the story of the Flying Toolbox, a groundbreaking concept that marks the dawn of mid-air robotic tool exchange, a convergence of technologies that promises to reshape our world. To fully appreciate the significance of this revolution, we have to understand the parallel journeys of its two core components, the drone and the robotic arm. Each has a rich history of innovation, and their inevitable union is creating something entirely new. The idea of an unmanned aerial vehicle is surprisingly old. The first recorded use was in 1849, when Austria attacked Venice using explosive-laden balloons. These were crude, unguided devices, a far cry from the sophisticated drones of today. The 20th century, with its two world wars, became a crucible for drone development. The First World War saw the creation of the first pilotless aircraft, like Britain's aerial target and the American Kettering bug, which was an early precursor to the modern cruise missile. The term drone itself is thought to have been inspired by the de Havilland Queen Bee, a radio-controlled target aircraft from the 1930s. The name stuck. Throughout the Cold War, drones were primarily developed for military reconnaissance. The Vietnam War marked a significant turning point, with UAVs like the Ryan Firebee series being used extensively for surveillance, saving countless pilots from dangerous flights. But the real revolution happened at the dawn of the 21st century. The miniaturization of electronics, the advent of GPS, and better batteries fueled a commercial drone explosion. Companies like DJI brought user-friendly quadcopters to the masses, making aerial photography accessible to everyone. Today, countries like India have tens of thousands of registered drones, used for everything from agriculture to surveillance. While drones were conquering the skies, another revolution was happening on the factory floor. The story of the robotic arm is one of precision, power, and the transformation of modern manufacturing. The concept of automated machines is ancient, but the birth of the modern industrial robot can be traced to 1954, when George Devol filed a patent for a programmed article transfer. This became the basis for the first industrial robot, the Unimet. In 1961, the first Unimet was installed in a General Motors factory. Its job was to lift and stack hot, heavy metal parts, a dangerous and repetitive task. This was the beginning of a new era. The 1960s and 70s saw rapid advancements. The Stanford Arm, developed in 1969, was the first electrically powered, computer-controlled robotic arm. The SCARA arm, designed in 1978, provided a more efficient solution for pick-and-place tasks. Soon, robotic arms were a common sight in factories worldwide, performing tasks with a level of precision and endurance humans simply can't match. For decades, these two technologies evolved on separate paths. Drones owned the sky, and robotic arms owned the factory. But engineers began to dream of a future where they could be combined. This concept, known as aerial manipulation, equipping a drone with a robotic arm to interact with its environment, started to gain traction. Early research projects, like the European AEROARMS project, laid the groundwork. But the challenges were immense. A drone is an inherently unstable, constantly moving platform. The movement of a robotic arm can easily throw it off balance, causing it to crash. Researchers have spent years developing complex control algorithms and hardware designs to counteract these forces. While a single-purpose aerial manipulator was a huge achievement, the holy grail was always versatility. A drone that can only perform one task is useful, but a drone that can adapt to any situation by changing its tools is a true game-changer. This is the promise of the Flying Toolbox, a revolutionary system that allows drones to exchange tools in mid-air. In a landmark achievement published in the journal Nature, a research team at Westlake University in China, supported by researchers at Loughborough University, developed a system called the Flying Toolbox. This is a cooperative system of two drones, a manipulator drone with a robotic arm and a toolbox drone that carries a variety of tools. The core innovation is its ability to perform a stable, mid-air docking and tool exchange. The manipulator drone can fly above the toolbox drone, dock with it, and autonomously pick up a new tool or return an old one. This sounds simple, but it's incredibly complex. The downwash from the manipulator drone's propellers creates massive aerodynamic turbulence, making a precise docking maneuver seem almost impossible. The team developed a suite of ingenious solutions to overcome this. First, they designed compliant docking mechanisms. Think of these as flexible shock absorbers that can handle minor positional errors during docking. Second, they created sophisticated algorithms that estimate the airflow disturbance in real time and compensate for it, keeping the drones stable. Finally, they used advanced precision control techniques that allow the drones to maintain sub-centimeter accuracy during the entire exchange. The result is a system that can reliably swap tools in mid-air, a breakthrough that opens up a new world of possibilities. As Professor Xiyu Zhao of Westlake University stated, this breakthrough represents one of the most sophisticated collaborative behaviors seen in aerial robots. The ability to change tools in mid-air transforms a drone from a single-purpose device into a versatile, multifunctional platform. The applications are vast and transformative. Consider the construction and infrastructure maintenance industries. Imagine a team of drones working together to build a bridge. One drone could be equipped with a welding tool, another with a riveting gun, and the third with an inspection camera. With the ability to swap tools, these drones could work continuously, without needing to land and be manually reconfigured. This would be invaluable for tasks that are dangerous or difficult for humans, like inspecting and repairing power lines, skyscrapers, or massive wind turbines, all without costly and risky scaffolding. In search and rescue operations, time is everything. Drones already provide an eye in the sky to survey disaster areas. With tool-changing abilities, they could become even more effective. A drone could use a thermal camera to locate survivors, then switch to a gripper to deliver a first aid kit or a communication device. In a collapsed building, a drone could use a small cutting tool to clear debris and create an opening for rescue workers. In logistics and delivery, companies are already experimenting with drone delivery. The Flying Toolbox takes this to the next level. Imagine a drone that not only delivers a package, but can also use a special tool to open a secure drop box, or even perform a simple assembly task on arrival. In agriculture and environmental monitoring, drones could become tireless robotic farmhands. A drone could use a sensor to test soil nutrients, switch to a precision seeding tool to plant crops, and later use a specialized gripper to harvest ripe fruit. They could also be used to collect water samples from remote lakes, or plant trees in deforested areas. However, before our skies are filled with these robotic workers, there are significant hurdles to overcome. The first are technical. Maintaining stability while a robotic arm is moving is a monumental control challenge. Drones are also limited by battery life and payload capacity. Adding a heavy robotic arm and tools reduces flight time. These robots also need incredibly sophisticated sensors, like high-resolution cameras and LiDAR, and powerful onboard computers to perceive and understand their environment. Another major hurdle is regulation. As the number of drones in the sky increases, we need a sophisticated airspace management system, like air traffic control but for robots, to prevent collisions. For most of these applications, drones will need to operate beyond the visual line of sight of a human pilot, which requires extremely reliable and secure communication systems and clear government regulations. Finally, we must address the ethical questions. Drones equipped with powerful sensors raise serious privacy concerns. If an autonomous drone causes an accident, who is responsible? The owner, the manufacturer, the programmer, and perhaps the most serious concern is weaponization. The same technology that allows a drone to wield a welding torch could be used to wield a weapon. Society needs to have a broad, inclusive conversation about these issues to ensure that the development of these robots is guided by a strong ethical framework that prioritizes human safety and well-being. The dawn of mid-air robotic tool exchange is not some far-off fantasy. It is a reality unfolding before our eyes. The Flying Toolbox is just the beginning. In the coming years, we can expect aerial manipulators to become more capable, more autonomous, and more integrated into our daily lives. This is the future that is being built. A future where the sky is not just a space to be traversed, but a new frontier for work, for innovation, and for human progress. The journey has just begun, and the possibilities are as limitless as the sky itself.